Hello friends, welcome to the session on digital image processing. In this session, we'll be discussing about the different image types. We know that whenever we want to process a digital image by using some computer software such as MATLAB or Scilab, then in that case, we need to store the image in appropriate format. So different softwares will provide the different formats or data types through which the images can be stored on the digital computer systems. So we need to understand what are the different image types that are available in MATLAB or Scilab and how these images can be processed or how the different operations can be performed on these different types of images. Friends, as you know that you are viewing this session on my YouTube channel, and you can subscribe to the channel so that you can watch many other educational videos. And these videos are prepared on the various topics of the subjects of electronics and computer science. So let us revise again what we mean by the digital image. We know that whenever we have any image, then this image is basically consists of different dots. So these dots are being called as the pixel. And in case of digital images, you can say that the image can be defined as a two-dimensional function f of x comma y, where x and y are the spatial or plane coordinates. And the function will return us a value. And this value is normally represent the intensity or the gray level of the image at that point. So as shown in this window, one can easily observe that image is basically a table which will consist of the different pixels, and every pixel will have a certain intensity value that can be given by the function f. So image will have number of rows and it will have number of columns. So one can say that x and y and the amplitude of the f, all these values must be finite and they must be discrete values. And when they are discrete values, then we can say that the image is a digital image. And whenever we process such digital image by using computer system, then that processing is being called as an image processing. So digital image will consist of finite number of elements, and each element will have a particular location and each element will have a particular value. So as I said, these elements are being called as the pixels, or sometimes they can be called as picture elements or image elements. So whenever in computers we want to represent an image, then the image can be represented mathematically by a function f of x comma y. And this function is just nothing but a matrix which will consist of the intensity values for the pixels at the different positions as shown in this window. Image can have a different data types. These data types can be called as a data class for the images. So whenever we store image by using MATLAB or Scilab, then we need to store the image by using certain formats that are being prescribed in the softwares such as MATLAB and Scilab. So as we store the different variables that belongs to the different data types, some variables can be of integer type, some variables can be of real type, some variables can be of character type. In the same way, we can have the images, and these images can belong to the different data types or data values. So data class will refer to the way the image elements are being stored into the MATLAB or Scilab. Various data classes are being available and that are being supported in the MATLAB or Scilab software. So you need to choose the appropriate data type so that the further processing can be easily made on the image. So there are different data types available as shown in this window. The first one can be a double, where we will have a floating point number representation of the image. Unit 8 is normally unsigned 8-bit integers in the range of 0 to 255, that is 1 byte per element. And this is the most common data type that is being used for the gray images. Unit 16 is the unsigned 16-bit integer in the range of 0 to 65535, that is 2 bytes per element. Unit 32 is the unsigned 32-bit integer, which has a much larger range for the intensity values. Integer 8 is the signed 8-bit integers. Integer 16 is the signed 16-bit integers, where the range will differ. Integer 32 is the signed 32-bit integers, where the range is much increased, where 4 bytes per elements are used. We can have a single precision floating point number. We can have a characters where 2 bytes are used per element, or we can have a logical data class or data type where the values are always in the range of 0 or 1. There is 1 byte per element. So one can easily find that most of the classes are of the numeric type, but it is also possible that you can make the use of character and logical as a data class for the images. So let us understand the different types that are being supported in the Scilab or MATLAB. You will find that 4 types of images are being supported: intensity images, binary images, indexed images, and RGB images. Intensity images are just nothing but the grayscale images. So most of the time when we are studying the image processing, then what we are doing is that we are dealing with the grayscale images. So these grayscale images are being called as the intensity images. So where the data matrix will represent a value and where each value will represent the intensity within some range. So grayscale images can be represented by a single matrix where the matrix value will correspond to the individual element value, that is just nothing but the pixel of the image. So for example, if the matrix is of the class 8, unit 8, then the grayscale images will have the pixel value in the range of 0 to 255. Or in case of unit 16, the value can be in the range of 0 to 65535. In case of double, you will find that every value can be a real number in the range of 0 to 1. Sometimes we need to process with the binary images. So where the binary images you can say is a logical array which will consist of zeros and ones. So a numeric array can be converted into logical array. And for this conversion, we need to make the use of the logical statement. So for example, we can have such type of the image where every pixel can be either represented by 0 or 1. There are certain indexed images where the index image consists of the data matrix X and the color matrix map. So map is a m by 3 array of the class double, which will consist of the floating point values in the range of 0 to 1. So each row of the map specifies the red, green, and blue component of the single color. So for example, if we have a small part of the image, then that image can be represented by the numeric values as shown in this window. RGB images are the red, green, and blue images, which can be called as a true color images, and that can be stored by m by n by 3 data array, which will define the red, green, and blue color components for each individual pixel. So whenever you want to show the color images, then color images can be represented by the RGB images. So RGB images do not use a palette. The color of the each pixel is determined by the combination of the red, green, and blue intensities that are stored in each color plane at the pixel position. So for example, we can have such type of the image, which can be called as a RGB image. It is possible that you can make the use of MATLAB or Scilab in order to process the image or in order to perform operations on the image. Say for example, if I have a certain image and if I write IMF info n1.jpg, then you will find that the content of the image will be displayed on the console, where the width will be displayed, the height will be displayed, the data type or data class will also be displayed. You will find that we can convert the one type of image into another type of image. So for example, if I consider a image matrix F is equal to 1, 2, 3, 4, then I can convert this into gray, matte to gray, and you will find that the values will get changed like this. So 1 will be represented by 0, 2 will be represented by 0.3, 3 will be represented by 0.6, and 4 will be represented by 1. If I convert it to image to black and white, and if I mention this G, 0.6, then I can get the value as false, false, true, true. So if I have a image matrix, H is equal to 25, 50, 128, 200, and then we can perform the operation on this image, matte to gray, and you will find that the content of the J will now be modified as shown in this figure. So it is possible that you can convert the image of one type into another type by using these functions that are available in MATLAB and Scilab. Image to unit 8, image to unit 16, matte to gray, image to double, or image to black and white. So the input form should be unit 8, unit 16, double, double, and logical. And you will find that the output will be in this format, while the valid input can be of this type that is being shown in this table. So whatever is the type of your image, if you want to understand what is your type of the image, then you can make the use of this command, IMF info, followed by the name of the image and extension. And if you want to convert the image from one form into another form, then you can make the use of these functions that are readily available in the MATLAB or in Scilab. So thank you friends for viewing the session. Hopefully you have understood what are the image types and how it is possible to convert the image from one type into another type. Thank you all.